Hey everyone and welcome. My name is Obed from Embed Systems. So today we are delving into the world of edge computing and AI with NVIDIA Jetson platforms. So these little devices are bringing AI out of the cloud into the real world. They are enabling truly incredible applications. And today I have the AGX Orin 64GB Developer Kit and we're going to unbox it, set it up and try out an example from Jetson documentation. So welcome. Let's start with a quick intro to what Jetson is. Essentially, NVIDIA Jetson is a series of embedded computing boards that give you supercomputer capabilities in a tiny form factor. So, and what are they used for? Well, Jetsons are incredibly versatile. As you can see here, they are being used across a huge range of industries. Think autonomous mobile robots in warehouses, smart city applications to improve traffic flow, advanced manufacturing, and even in healthcare. From delivery robots to medical imaging, Jetson actually is powering the next wave of intelligent machines. NVIDIA offers a range of Jetson modules to fit different needs and budgets. You've got everything from the Nano for smaller projects to the Orin for more demanding tasks. Today, we are going to focus on the Jetson AGX Orin. It is a powerhouse delivering supercomputer-level performance for advanced AI robots and even computer vision. The AGX Orin Developer Kit is essentially useful because it can emulate other Jetson Orin modules, which make it easy to start developing your AI projects. So what makes Jetson so effective is not just the hardware, but also the powerful software that comes with it. NVIDIA provides a comprehensive AI software stack. Tools like the DAO toolkit allow developers to train, adapt, and optimize custom models, and DeepStream SDK makes it easier to build and deploy intelligent video analytics. So to get started, you use the NVIDIA SDK Manager, which has everything you need to set up your development environment, and I will demonstrate this much later. So for high performance, NVIDIA provides TensorRT, an SDK for optimizing deep learning inference to give you low latency and high throughput. So that's a quick overview of the NVIDIA Jetson platform. Hopefully this gives you some context as we move on to the main focus of this video, to unbox and set up the Jetson AGX Orin. And I will just focus on using the NVIDIA SDK Manager, and then we will do an example. Okay, so these are all the contents of the box. So here we had the power cords and power supply, and then we had a little support guide that you can use to set up the first time. Then you have the Jetson itself. We had USB-C to USB type A cable, and so yeah, this is the board. So on this side we have the first button with a power button, and then in the middle we have a force recovery button, and on the right we have a reset button, and next to it we have a micro USB port. Then flipping it around, we have another USB power port here, USB-C. Then you have Ethernet, we have two USB 3.2, and then you have a display port, and then you have a micro USB 2 for debugging. Then at the back we have another USB-C. We will use it just for setting up the board using the SDK. We have a 40-pin expansion port and two other micro USB. So below it, so here we have, when you buy it, it doesn't come with the SSD, so it provides a PCI or an NVMe port for SSD support. So I have installed PCI 4.2 M22280 SSD card from Micron. This is important for large language models that require massive amounts of memory. And then you have a Okay, now we have set up everything, connected everything to the board, and we have also set up the screen and the keyboard and the mouse, and I have now a host computer that is installed with Ubuntu. And in the next process, I will explain how to flash the Jetson with the Jetson OS and also the software packages. So we have a USB-C connected to the PC, and then have a mouse and a keyboard connected, and I have a display port connected. And now what is left is to connect the power board to. So once you connect the power to the board, it just puts the board. So I will wait until the right time and then I will proceed. So yes, so we have the setup and ready to go. Okay, so for this setup, you will need an host PC that is formatted and working on Ubuntu operating system. And according to NVIDIA, the Jetson SDK supports only few versions of Ubuntu, and this is Ubuntu 20.04 and 2022.4. And you should make sure that you comply to this requirement, and please check the latest version supported so that you. Okay, so you first need to download SDK. So I will just download SDK, NVIDIA SDK manager. You have to download it, and so in this website it tells you you need to have Ubuntu 20.04 and Ubuntu 2022.04. So you will download the version according to your Ubuntu version, and as I already did it, so I will just simply run it. So in this case, I will open the terminal and then do SDK manager. Alright, so in this case, for you to use the SDK manager, you need to have an NVIDIA developer account. So in your first time to open this, you need to sign and log in to your account. So I already did, and this is the web. This is how this looks like in your PC when you have installed the SDK manager. So you see here, there's a target device. It's not detected. So this is the point where we want to connect and set up the board. So what I do is I will connect this to to the board in recovery mode. So I will show you this. Okay, so now to connect the board into recovery mode, press the middle button. While pressing it, connect the power cable to the power port in USB-C. So hold for a few seconds and release. So what you will realize once you do that, on the host side you will see a message that the SDK manager has detected a connected device which is running in recovery mode. Now we are good to go. Okay, so once we have this, you select the Jetson that you have. In this case we have the Jetson Orin 64 Developer Kit version. Select it and say OK. So you select and unselect the host machine, and then you choose which version of Jetpack you want to install. So 6.2 is the latest Jetpack. That is the software platform and packages that you need for various applications. So I want to install a different version that I will need. So I will check show all versions, and then I can select the one that I need. I want to install Jetpack 5.12. So once you do this, you continue to the next step, and here it will download based on your internet speed. This sometimes can take a few hours, but I did already download this before. So the first thing I will do is I will just connect and I will install the Jetson Linux version first, and at the same time I will then install, let me just install the Linux only. So what happens here, you just need to flash the Linux operating system to the device first. So you must accept the terms and conditions here, and sometimes you can just download it and install later. So this is what I did before this. And then having selected that I'm only going to install the Jetson Linux, and then I can now proceed to the next step. Remember, we are in recovery mode, so the board is on. And then so for administrative purposes, it will ask me to enter my password. So once you do that, it's going to verify the system readiness to install. It will check if there are any issues. So normally if you have any issues on your board, on your PC, then it will give you alerts. And so it's creating the OS image, and then it will flash the board. So we will have to wait for this process. Okay, so at this point, the SDK manager is about to flash your Jetson, so you will do some setups. Here you have to select the device already selected. We have to do here we have two options. Either you do pre-config, where you set up your username and password, or do it at runtime, that is after you put it up. But now we will use the pre-config as it is. Set up your new username. In this case, I am going to say Hero AGX. Sorry, I'll have to do some, yes, this way. And then I want to set a password. So you can set your flash to either of these devices. You have the eMMC, that is internal. So the Jetson board comes with a 60 GB internal storage that is based on eMMC. And then, as I said earlier, I have installed an NVMe SSD card and SSD storage. So this is what I'm gonna use. And then you can also use other methods, USB or even SD card. So I'm going to use NVMe. So one important thing here that I forgot to mention, that sometimes you need to set up deactivate the firewall for you to do this, because of the transfer of data between your host's computer to the board. Yeah, but I already did this, so if you have an error with this one, then you will have to do that. So now, having said this, I will just click flash. Okay, now yeah, see, at some point now it will start displaying something, and yeah, it's doing some setup on the screen. So yeah, so meaning it's done doing, it's almost doing finishing the setup, and sometime you will hear pop-ups on the SDK manager indicating storage connection. And yeah, so here we are, it's trying to verify. So we see that is it has a complete Ubuntu configuration. And yes, so when you go back to the SDK, it has already finished. Yes, installation complete. And now you have it. Now here, it's here. Now this is our Hero AGX. You just need to give it a password. And there we have it. So we have our NVIDIA, and the setup is complete. So this was the setup to install the operating system, the Jetson Linux operating system. So in the next step, we will install the packages that are required for acceleration of deep learning and AI models on this board. So once the Jetson Linux is already installed, our next step is to install the SDK components to the board. And to do this, we again use the SDK manager. So it will bring up the manager again. Remember this, you have to log in, and I've said I will stay logged in as long as I'm in this computer. Now it's saying it has detected a connected device which is running in normal mode. Okay, so we have to select this board and then select OK. So deselect the host, and then we select the Jetson that we were used to installed, Jetpack 1.2, 5.12. So I will select it again, and then I move to the next. So in this step, we already installed Jetson Linux, so we deselect it, and then we select the remaining components, and these are the Jetson runtime components. These include the CUDA runtime, and then we have the CUDA X AI. These are the tools that we need for running the models on the board. So again, remember, you deselect the Jetson Linux, and then we accept, and then move to the next step. Again, you will enter your password for administrative tasks, and here now you are asking the SDK manager to install the SDK components. So this is where the USB connection is important. So you have to select the connection here. We are using a USB connection. Remember the USB type A to USB-C that we made. And then this is the IP address of our board. And then you have to set, just remember to say our we have to write our username and password of the board. So remember, we used hero-agx and then the password because it will need this for connection. So and then now we will just press install. So then this also is going to take some good amount of hours. It will just check and verify the readiness of the board. Internet connection, you need a pretty good internet connection, and then yeah, so this will take a while, and you can monitor the installation process until it's 100% complete. And it's done, right? So the installation is complete. We have all the Jetson SDK components. There is CUDA, TensorRT, and all the runtime components installed. So you can simply just finish and exit. So from this point on, we will be working on the Jetson itself.
Okay, so this is actually the Jetson. It has booted now already with the operating system, and we already installed the SDK components, that is including the CUDA drivers and everything that you need. So here we have an Ubuntu system. Actually, you can just check the version of Ubuntu that is installed. You just go to the settings. And yeah, so here the device is booted to, okay, these are the hardware specs. You have a processor of ARM v8 processor, and we have 61 GB of memory RAM, and then we have a NVIDIA Tegra Orin GPU, and I installed an SSD that is 2.1 terabytes, but you really don't need this much. You just maybe need, in fact, even an SD card of 128 GB is enough. And then we have Ubuntu 20.04.6 LTS. So this is it. And then for you to actually know the exact L40 version that you have installed, you just go to the terminal and then use this command to find out. So find the version of the L40 version, and this is important when you will be trying to find images or containers that are relevant and compatible to your system. So here we have R34 version 4.1. So this is important to remember. So this is an ARM architecture 64. Yeah, so this is important. Now, so having installed the Jetson software, we just going to do an example of running a large language model on this device. So here there are links to various pages that can help you. So I will just go to, for example, the Jetson Zoo. You can go to the Jetson community, and there are forums, support forums, and developer zones. So let's see this. Let me open this one. So here is the Jetson Zoo. It provides you some information about what Jetson can provide. So here it says that Jetson Jetpack that we installed comes with pre-installed components such as the L40 kernel that I showed you, the CUDA toolkit, TensorRT, OpenCV, GStreamer, and many other Docker and other things. So it introduces what we call the Jetson AI Lab. So this is how like tutorials on large language models, vision transformers, and vision language models and all this. So this is the information, and it tells you many other things you can do installing of various frameworks like PyTorch, TensorFlow, ONNX, and others. So I will straight away go into the Jetson AI Lab. So here we find other tutorials that can we can just run. It has a number of tutorials and simple projects that you can build on. So I want to go to this page in tutorials, and there are still so many. I want to test a vision transformer. So a vision transformer is one of these great applications that we have now with the large language models and transformers. So there are a number of them, and this efficient VIT, this nano all. I want to try this one. It's a VIT. So I will try to follow these instructions in this tutorial. And of course, sometimes you will find errors, so we'll try to face them as they come. So the first thing is to download this or clone this repository. So I'll just come here and copy this and go to my terminal and then paste, and then it will download this into the Jetson containers folder in our home directory. So it will take some few minutes. Yeah, it's done. So I will then install this. So I'll just do this bash Jetson, install it as a script to install this, and yeah, so it will take a few minutes and it will be done. Okay, it's done. So we have installed the container or the Jetson containers. Now we will start to try this. So we just run this container. We want to run this example using the command given here. So I will just paste it here and then try to run it. Okay, so here is an error. So it cannot run the container because of an error, and when you try to read this, probably the error is from giving this JSON container networks.py. It says that this module func tools has no attribute to cache. So I found this error and I tried to find it because this Jetpack that we installed uses is running on Python 3.8. So you can actually find out. You open the command and then write Python 3. So it's using Python 3.8, and the func tools package in Python 3.8 does not have this attribute cache. So how do we know? Let's just use this Python environment here and test. So you can just test it using, if you try to import Python, import the func tools here. So for example, if you come here and then try from func tools, import cache, you realize this is the same error here, so we cannot find this. So what happens is that this cache is not the same way, its implementation is not the same. So apparently this container is based on Python 3.10. So our workaround is to change this import that is in this file network.py, and we will have to
try another way. So from functools, I think you can find in 3.8 it can be imported as this way: LRU cache. So if you import this, it's okay. So you can actually replace this as cache. So this is the better implementation. So I think the version of Python that was implemented with this on this container is based on 3.10. So we have to change this in so actually we can go to the GitHub repository, and I found out that in the Jetson containers networks.py it is using this PyTorch, this function tools.cache, and this is why we have the error. So how do we change this? Is either we go to the files and go to the home directory, and then JSON containers, and then go here to the, I think you see the packages containers, and then here to the network. So network py. So here you will find that this is the function we have here. So it's either you find all the implementations that are using this, or this a command we can write on the terminal to do this for us. And this is the path that I'm going to take. So let's come here. Let's just go to the container and then write this command. This will search and replace all the imports to cache to be in a proper way. So I will use this command, and then you can copy it as well. So we want to find this. So actually we want to find the function, as we saw that it's functools. Okay, just make sure you have it properly typed. So we want to find it in this directory, and then we want to replace it. So we want to replace that with the more compatible version. So we want to find functions. So once we do this, we want to replace it with this instead. Remember how we did it here, so that is what we want to do. And then there's an argument that probably we will include. So we will say max size the question, and just use this. It will go fix this. So this is the command. So this will automatically decorate all the invalid decorators with the ones that is working. So now that is done. So what we'll do is now again try to install the containers afresh using this command here. So once that is done, okay, this is done. So successfully build the Docker Hub API. So then go back to our, and then we will now move how to start this Docker. And so we copy this again and try to run it again now. So, all right, okay, it's now running. So we are in this Docker container. So this is where we are. Now again, we want to check if we have our video or camera connected. And see
index and then find it. Yeah, so we have our video 0, video 1, so we'll use this. And then according to the installation and this documentation, there's this module that is missing in the container. So you copy this and install it. It's done. So let's launch this example. So let's go into this folder, example 3 demo. Okay, and then once we are there, we can now run this. Let's try to run this code as it is here, this command, copy. And then let's run it here and see if it's going to run. So it has some arguments and okay, it's an error. It's saying it doesn't recognize this resolution. So I think these versions of various Docker containers, sometimes they have different implementations. So what I will try to do is try to follow this usage. And it's going to tell us it needs an image quality, which you do not know how to implement this. It needs a port, it needs a host, it needs a camera. So I can provide you with a camera and then an engine, then we can let it use the defaults for these parameters. So I will try Python 3 and then I will give it the file, and then I will use the camera argument, give it camera number 0, and then give it the file, which is we installed at data, the image. So what this will do is try to take this image that was already built using TensorRT and create a plan that is now going to be run on the GPU. So okay, so this is going to build this, and then soon we'll be able to have the application running. Yeah, so it has many errors here and there, but as long as it runs, we are good to go. Yes, so let's see it run. It's about to finish. So it will open this application in a browser with an IP address of the Jetson, and then on that endpoint we will be able to see the application. So yeah, it's about to finish. So it will be giving you some errors. So here this is a TRT, this is TensorRT, giving you a warning that once you create a plan, you cannot use it across different models of the device. So if you build an engine and plan using this Jetson AGX, you cannot use it in another Jetson device like the Jetson Nano. So this is what this means. And you can dig deeper into this kind of implementations and know more. So it's opening the camera, and yeah, so here we have it. So open this link, and yeah, so here we have our camera. So the camera that I have is not of good resolution. So this is how you interact. You can prompt this application to find maybe a face. Okay, so here it can be able to find a face, and then you can also ask it to find a nose.
right, it can be able to find a nose, and then you can also ask it to find an ear. Okay, I noticed now it cannot tell it's an ear, it just wants us to tell it an ear. A ear. Okay, let's use an eye. Right, it can, and then it can find a mouth. I think so. Okay, so it can find a mouth. So that is how it's able to work. And then let's see if it can see the computer behind me. The screen. Okay, it cannot work. It cannot find it. Let me give it. Okay, it can find the screen behind me there. And let's see if it can find a person. So yeah, it can find a person. I need to move behind a bit. And then on this person, it can find a face. Okay, so it has to find a person, and then it finds a face. Okay, so that is when it can find me. So otherwise, we can just ask it to find a face. And yeah, so that is how it works. So for you to go deeper into this application, then you will need to go into the documentation of this and find how this implementation is done. And in the Docker itself, you will be able to find the source code and see how it's implemented and see what you can change. So here in the GitHub, you can have other examples. So here is the implementation of this. We have been able to do this, and then you are now free to maybe try out other kinds of implementation like this VIT, efficient VIT, nano sum, and these are segmentation based. Yes, so that's it. So have fun with this and see what you can do. So just another quick, you can actually find about apart from the large language models, you can try the Jetson inference that it's based on the deep learning models on classification, detection, and segmentation. So it's a very nice also repository. So you can find more about this.